Hi, welcome back. So in this video, we are continuing our discussion of how we find trigonometric values for any angle. So this is for angles that aren't our special angles on the unit circle. So in the last video, I talked about how we can do this when we're given two side lengths and the quadrant of the angle. This time I'm going to talk about how we do this when we're given one side length and one of the angles. So let's jump into it. As a note, this type of example requires a calculator most of the time if you want to get like a decimal approximation, so you'll probably want to have a calculator on hand if you're working through the examples in this video along with me. Okay, so we're going to do an example, and we're going to find the missing side lengths and the angle measure in the triangle below. So in this problem, we aren't specifically asked to find the trig values, but we're going to need them, and you'll see why in a minute. So the prompt here is to find the missing side lengths and the angle measure. So I'm going to give you the picture of the triangle, and I'm saying that our angle is 18 degrees and then 25 as the hypotenuse. Also, I've drawn this triangle in the first quadrant, so you can assume that the side lengths are all positive. So the side lengths we're trying to find are x and y, labeled here, and the angle theta, which is the other angle in the triangle. So I'm going to start with the angle theta first, just so we can make some more connections. In a right triangle, or in a triangle at all, the angles need to add up to 180 degrees. So here I have 90 degrees as one of my angles, and then I have 18 degrees as the other, and I need to figure out that third angle to have them all add up to 180. So I can write an equation that says 18 degrees plus 90 degrees plus theta, whatever that is equal to 180 degrees. Then I'm going to solve this equation for theta. So 18 plus 90 is 108, and then I will subtract that from 180. So I'm getting that theta is 180 minus 108, and that is 72 degrees. So I found my angle, and it is 72 degrees. Now we're going to get into the parts that actually require the trig functions. So in order to find these sides, I'm going to set up trig functions that involve them in some way. So let's start by trying to find x, and I'll show you what I mean. So I want to set up a trig function that somehow involves x. So starting at 18 degrees, I see that x is the adjacent side, and I know that cosine is adjacent over hypotenuse. So I can say that cosine of 18 degrees equals x, the adjacent side, over 25, the hypotenuse. And this just has one unknown in it, and it's the side length I'm trying to find. Alternatively, you could use the angle 72 degrees and see that x is across from it, so it's the opposite side, and we could use sine. So sine of 72 degrees is x over 25. Now I'm going to stick to using cosine of 18 degrees instead because I like to use the angle that was given to me in the problem. Now to solve for x using the cosine of 18 degrees equals x over 25, I'm going to multiply 25 over to the other side. And so I have that x is equal to 25 times cosine of 18 degrees, which if I use my calculator is approximately 23.78. So my side length, that is the x, is 23.78. Now I'm going to repeat this process for y. So I'm seeing that y is opposite from 18 degrees, and so I'm going to set up that sine of 18 degrees equals y over 25. Alternatively, if you wanted to, you could start with the 72 degrees and do that cosine of 72 is adjacent, y, over hypotenuse, 25. Again, I'm going to use the sine of 18 degrees because the 18 degrees is the angle I was given, and I'm confident that that one is accurate. So I multiply 25 over in order to solve for y, and I'm getting that y is equal to 25 times sine of 18 degrees, which is approximately 7.73. And I can label my side length. And there we go. We found the missing angle and the two sides. Now, just as a comment before we wrap up, I want to throw out an idea. So you could check the accuracy of your side lengths by using the Pythagorean theorem. So Pythagorean theorem says that x squared plus y squared equals hypotenuse squared, which is a squared plus b squared equals z squared. So because we rounded our values, we're not going to get like exactly the right thing. So this is why I don't recommend using the Pythagorean theorem when you're trying to find the answers to begin with, because the rounding might be a little off. But we can use it to check. So let me show you. I'm going to do 23.78 squared plus 7.73 squared and check, is this equal to 25 squared? So I'll write those decimals out here. I just squared each part. And when I add everything together, I get 625.2413 is about equal to 625. So, as I said, they're not going to be exactly right in most cases just because we're rounding when we write down those decimals, but it tells me that I was on the right track and I got really close answers, and they're probably accurate just due to rounding. They're a little bit off here, and so I can feel confident in my final solution. All right, so those are some examples of this second type of problem you might see where you need to use the other trig functions. Although here we really only used sine and cosine, so I guess this isn't all that new. We're just doing it now that you have seen all the trig functions and really started to think about using them outside of just our unit circle values. Thanks so much for watching, and I will talk to you in the next one.